this is our system schema for a train moving at zero velocity. The earth, we have the bottom of the cup, the back of the cup, and the front of the cup, which is all acting on the cup, which is containing the liquid. And Ryan will explain this further in his force diagram.
Okay, here you have the force diagram for our cup at a zero velocity. As mentioned in the system schema before, the forces acting on the cup and the liquid inside the cup are the back of the cup, the front of the cup, the bottom of the cup, and gravity itself. Gravity and the bottom of the cup are acting as vertical forces, and as you can see in the graph, they're congruent or balanced, for example. What this basically means that the vertical forces acting on the cup and the liquid inside the cup are balanced, keeping it from, say, floating off everywhere. The horizontal forces acting on the cup are the front and the back of the cup. Those two are also balanced, and basically these act as seat belts per se for the liquid, which keep it inside the cup and floating from either side of the cup.
Here's our system schema for all of the forces acting on the liquid and the cup containing that liquid. Train going at a non-consistent velocity. We have the front and bottom of the cup, and Earth again representing gravity. Ryan!
So here's our force diagram for the cup going at a constant velocity. It's very similar to a zero or constant velocity, except we have excluded the back of the cup because the train is going to the right at a non-constant velocity. So basically the back of the cup is rendered irrelevant. As you can see here, as before with the other two force diagrams, the vertical forces of the cup are balanced, meaning it's staying in place. But as you can see here, with the train going to the right and the cup is technically not moving, and the train is sort of trying to leave the cup per se. And that explains why the front force is acting like this. Basically what happens is, as the train stops, the person holding the cup and the cup itself try to catch up to the train and reach its speed as well.
Great. Swag us out. Alright, so here are all of our forces acting on the cup for a train going at a constant velocity. They are the same, the front, back, and bottom of the cup, and Earth representing gravity. Ryan, please further explain that.
Alrighty then. So as he said before, this is the cup at a constant velocity, and this is the force diagram. Basically, it's the same as zero velocity. Basically, both of those velocities are the same. One's a zero constant velocity, while the other one's going at a constant velocity. Both the Earth and the bottom of the cup are acting as horizontal forces, keeping those forces being balanced, and the front and back of the cup are also balanced, but different balance forces, keeping the cup going at the same rate as the train.
Swag us out. Here we have a system schema for all of the forces acting on a cup containing liquid for the cup falling towards the ground. And here is very complicated. Only gravity. Gravity. Ryan?
Okay, thank you. So this is the force diagram for the cup falling. The reason why Earth or gravity is the only force acting on the cup, because since the cup is falling, there's no other upward force to keep the cup balanced from falling. And the vertical forces are rendered useless because the cup is falling.
Here is our system schema for all the forces acting on a cup and the liquid inside of it for a cup hitting the train floor. Here we have Earth representing gravity and floor. Ryan. Hey! Elevator.
Wait, what? I'm just going to cut that in. Here we have the force diagram for the cup hitting the floor. As mentioned before in the system schema, the only forces acting on the cup are Earth/gravity and the train floor. Now, as you can see, this force diagram is a bit different than the other ones. Neither of the forces are balanced. Now, why is that? When the cup hits the floor, it stops immediately. Now, why is that? Because gravity is actually imposing a weaker force than the floor, and the floor is actually imposing a greater force than gravity, which is why you see the water or liquid or coffee sort of splash upward, because the force that the floor is pushing on the cup is greater than gravity. So,
Who's ready for a demonstration?